Hello, my name is Sean Morden, and today I will demonstrate a technique called process mining using the process mining tool Disco that has been developed by Fluxicon Software. First, let me give a brief explanation of what process mining is and then outline what the benefits are by taking such an approach. Process mining is a technique to discover, monitor and improve real processes by extracting knowledge from event logs readily available in today's information systems. The benefits are as follows. Process mining will help you improve revenues, for example increase capacity, reduce cost by removing waste, and mitigate risk by gaining a greater visibility and thus control over your key business processes. For today's demo, we will take a look at a purchasing process. I will import some data and look at it from both a frequency and time performance perspective. For process mining to work, the file being analysed needs to be prepared. This means assigning a case ID tag, an activity tag, and a timestamp tag to one or more columns in the data file. So let's get started. The case ID tag is assigned to the identifier of the process instance. For the purposes of our demo, this is the purchase order number. So let's assign the PO number with the case ID tag. Here we can see that the symbol has changed to the case ID tag in the purchase order column header. Next up is to assign the activity tag. These are the tasks that get performed to the purchase order. So in this instance we assign the work type column with the activity tag. Now we need to identify a timestamp. It is necessary for a timestamp to be present for the start of each activity in the process instance. This is for sequencing purposes. Note though that we can also use another timestamp for when the activity completes, thus allowing for us to measure both active and passive time. Right, now we're ready to start the import. So straight away we can see that we have reverse engineered the data back into a process model. Now let's zoom in and take a more detailed look. Here, the model is presented from a frequency analysis perspective. That is, how often each task is executed. From the screen though, we can see that the interface is both highly graphical and intuitive. Now if we take a look at the start of the process, we can see that there are 608 process instances, all starting with the create purchase requisition activity. But note that after this the process diverges into two paths. Also we can see that the activities are in differing shades of blue, the deeper shades of blue indicating the most frequently executed activities and the lighter shades identifying those executed less frequent. So in this example we can see that the analysed request for quotation activity is the most deepest blue, and that is because it has the most activity executions at 1107. But we know that there are only 608 process instances. This indicates a huge opportunity for some process improvement effort. Similarly, the same is true for the connectors between activities, those darker, wider, more prominent arrows guiding us down through the most frequent paths that the process takes, that is, the most frequently occurring process variants. To finish, I will demonstrate some time performance analysis functionality, looking to see what possible constraints might exist, in effect identifying constraints to flow. So let's switch over and we look at the average duration of the active and passive times. What we can see again is that the analyzed request for quotation is at the center of some problems. While on average the activity itself takes only 23 minutes, we can see that the passive time between this and subsequent activities can be in or around 11 days. This is important to know because, as in this example, activities themselves do not take much time, but waiting to perform them can be what causes the constraints. Needless to say, there is a lot more functionality available in Disco, but for now I hope that you have found this introduction relevant. Thank you for watching.